Alright, good day guys, how are you all doing? Actually, in my previous video, I talked about inequalities and how to use strict and weak inequalities with some little examples. And I said I would proceed. And actually, we ought to talk about fraction, solving fraction with inequalities and some things like that. But I guess bringing this into your idea is not also bad. Now, we're talking about absolute value of inequalities, and mainly this also just talks about normal absolute value. Are you with me? Your normal absolute value, which is needed here. Now, if you are being given the symbol of, this is a strict inequality and this is a weak inequality, as we all know. So let's say you are being given the symbol greater than or greater than equal to. Are you with me? If a is greater than 0, that means that this value here, it is actually greater than 0, the value you are going to be given. Then the solution to that value, the absolute value of x being greater than a, are you getting what I'm saying? The solution to that particular value being greater than a is going to be x greater than a or x less than the negative a. Now all this here becomes sensible or makes sense when you are dealing with examples. So if the solution to the value when it is greater than a is x greater than a or x less than minus a, and the solution to the value if it is greater than equals to a is x greater than equals to a or x less than equals to minus a. Now coming back to it, now talk about the greater than and the greater than equals to. Now what if the symbol is less than or less than equal to? This is what you have to do. If also again the value you are being given is greater than 0, that means 1 upward, the solution to the absolute value of x when it is less than a, it's going to be x less than a and also x greater than minus a. So it's very easy to understand. If it's less than, you have x less than a and what's greater than minus a. If it is less than equals to, you have what less than equals to a or greater than equals to minus a. Now listen guys, this is one major issue that you need to understand. And I would call your attention that take note of something is that if x is greater than minus a, it can be written back as this: minus a is less than x and also less than a. Now please do not make the mistake of it saying, okay, we have x less than a here, we have x less than minus a here. This is still understandable, let me put it that way. Minus a less than x tells us that this variable value is less than the function and the other values that are coming in as a solution to this. So not minus a less than x and greater than a. That would spoil the whole plan of this. Are you getting what I'm saying? So if also is less than equals to a, then x will be less than a and also your x would be greater than equals to negative a, and it can be written back as minus a is less than equals to x and also less than equals to a. Now most cases you have to treat the negative value first. You have to always look at the negative value to put in a way whereby it has to be less than the normal value you are being given. But let's talk about a particular example. If the absolute value of x minus 10 is greater than 5, I told you guys that this now greater than, what's the problem? Greater than a, less than minus a. So for the first case, your x minus 1, your x minus 10 will be greater than 5, or your x minus 10 would be less than minus 5. We are obeying the rules here. Then automatically x would be greater than 15, or x would be less than minus would be less than minus minus 5. Minus to less than 5, sorry, not minus 5. So minus 5, then plus 10 becomes less than 5. Now how do we write this in a normal way? This is how you write it in terms of something like this. If you are to look, because x is less than 5, that is, you can easily say 5 is less than x. Are you with me? And also less than 15. That's how it's been written. That is, any value you have to insert here is judging both value of 5 and also 15. If I'm to insert 6 here, it tells me that, let's say 5 is less than 6 and also less than what? 15. Inserting 7 here, 5 is less than 7 and also less than 15. 8, 5 is less than 8 and also less than what do they call it? And also less than what? 15. Like that. So it has to be mainly judging this and also this together to know what you are dealing with. Now let's take another example. Let's say example 2. Let's say you have been asked to solve. Let me see. x minus 4 is less than equals to, you have your 5. Now if you have to look at this, guys, less than equals to, this is it here. And what does it tells us? You have less than equals to a and also greater than equals to minus a. So you have x minus 4 is less than equals to 5, or x minus 4 is greater than equals to negative 5. Are you with me? And solving this, your x is less than equals to minus 9. Okay, sorry, 9 plus 9. Let's just say ordinary 9. Or your x is greater than equals to, this comes here, becomes minus 1. Now let's settle the negative 1 first. Minus 1, you should know it says s greater than what? Negative 1. Now if s is greater than negative 1, it can be written back as minus 1 is less than equals to x. We can make it looks like something like this, so that whenever you are dealing with it, you will not have any issues. So if minus 1 is less than equals to x, when you want to put it in the normal range, you have minus 1 less than equals to x, and also less than equals to what? 9. So that's one thing you have to know, is that, so 4 minus 1 is less than equals to x and also less than equals to 9. Inserting any value like 0 here, you should know 0 is less than equals to less than 9, y minus 1 is less than what? 0. Inserting 2 here, minus 1 is less than 2 and also less than 9. So if I'm to insert, I can insert 8 here, whereas minus 1 is less than 8 and also less than 9, like that. So take note of these, guys. And if I'm to insert negative 1 here, minus 1 is equals to minus 1, but less than what? But less than 9. So that is the second example on the absolute value of inequality. Let's touch another example. Let's look at this. Let's say we have, let me see, something more. Let's say we are being given 4 plus x minus 5 less than 0. Now since it is less than 0, we all know what to do, right? And that will be less than a here. You have less than a or greater than negative a. But before you move that, I told you guys that there's an exception. It has to be greater than 0. But here it's less than 0. So what you have to do is that just shift it. 4 plus x would be greater than what? 5. Now it makes sense. Are you get what I'm saying? So now it is actually obeying the normal value. And moving on to this now, guys, you have your 4 plus x less than what? 5. Log to this is it here. Less than 5, and you have your 4 plus x greater than negative 5. So this gives us x less than 1 or x greater than minus 9. Now looking at this, guys, we all know that we have to deal with the negative 9 first and foremost. So minus 9 would be less than x and also less than what? 1. So that is our answer for this. So the next question, before we round up, let me take one more example to round this up. Let's see, what else do we have here? Okay, this is a good example. It says you've been given 6 less than x plus 2 and also less than 8. If you could remember vividly, I told you that if x is less than 9 minus 9, let me just say that way. I think that you can easily say minus 9 is less than x. So the same thing we are using here. You have to find the value of this and you can break it into 2 then. Are you with me? Now if you have to look at this, look. Let me drop one more example under this to make it easier. So like I said, if your value is 6, breaking it down, you have 6 less than s plus 2, right? And like I said, let's assume that you have x less than a. It's the same thing as a greater than s, a normal them. So if you are having something like this, this is a normal way to write it. Now since we know that this is a normal way to write this, then we can even say since 6 is less than this, you can adjust it as x plus 2 is greater than 6, and that is acceptable. And how do I know this? Simply because if your 6 is minus absolute value of x plus 2 less than 0, minus absolute value of x plus 2 will be less than minus 6. Dividing both sides, your absolute value of x plus 2 will be greater than what? 6. The sign changes. If you go and check my next slide, that's the other previous I did under inequality. Whenever you divide it by minus or multiply them by minus, the inequality sign changes. So that's what is being done here. So I guess you do not have any issue. X plus 2 will be greater than 6, or x plus 2 now would be less than 8. Two categories. Let's start from this category. Now, if your x plus 2 is greater than your value, which is 8, and I've told you guys, this is the law. Greater than, less than, minus. Greater than, less than, minus. So x plus 2 will be greater than 6, or x plus 2 will be less than minus 6. Let's start from this. Then your x will be greater than 4. So therefore, your x will be greater than 6. That's 6 minus 2. Or, notice the two cases. This is the first case, and this is the second case. So therefore, your x will be greater than 4, or your x will be less than minus 8. So we can easily write it at negative first. Minus 8 is less than x and less than 4. Case 1 completed. Then moving on to second case now. You have absolute value of x plus 2 less than 8. So you know your x plus 2 will be less than 8, or your x plus 2 would be what? Greater than minus what? Minus 8. Are you with me? Yeah, if you could remember vividly from our x plus 2 less than 8, this is it here. Less than and greater than negative value. So your x would be less than 6, or your x will be greater than negative 10. Yeah, 8 minus 2, 6. Minus 8, then minus 2, you have 10. So here automatically minus 10 would be less than x and less than 6. So that is our answer that is all rather for today. Next slide, we move on to absolute value of inequalities and also fractions aspect of the inequality. Moving on like that step by step. So we'll talk about some little proofs of using absolute value to prove some things in our next slide. So thank you for watching this. My name is Crypto Quanta.